This module focuses on developing an awareness of the conceptual shifts that frame the development of the next generation science standards. In 2011, a framework for K-12 science education was published. This framework is based on a rich and growing body of research on teaching and learning in science, and has provided the foundation for the next generation science standards. The conceptual shifts that we will be exploring in this module are based on the vision of this framework. The next generation science standards can be found at this URL. Here is a screenshot of the standards page. The conceptual shifts that we are going to review today are outlined in Appendix A. Use this Challenges and Opportunities of the Conceptual Shifts handout to record challenges and opportunities that apply to your own classroom, school, or district throughout this module. Before we get started, let's spend a little time thinking about what scientists do and what science students do in the classroom. With a small group, take the stack of cards and sort them into these two categories: things that scientists typically do, and things that science students in K-12 classrooms typically do. When you're finished, share your sorting results with other groups and compare answers. Discuss any differences you notice from group to group. Press pause as you complete these activities. As you consider the cards you've sorted, what does this tell you about the roles of scientists and K-12 science students? How are they similar? How are they different? Also, orchestra students are musicians, students on the basketball team are athletes. Do our science students have the opportunity to be scientists? Pause the video while you consider these questions with your group. Take a look at the Comparing the NGSS to the Michigan Content Expectations handout. What similarities do you see and what differences do you see? Pause the video as you consider these questions. One difference that's compelling to me is the rigor and sophistication of the NGSS as compared to the grade level content expectation as seen here. Plan and conduct an investigation instead of demonstrate. Develop and use a model instead of observe. The same kind of difference is prevalent at the high school level too. One can imagine that next generation science classrooms will have to be extraordinary learning environments. In fact, if you think about it, the NGSS are much more like the things scientists do from our card sorting activity. Now I'd like to take a look at one of the NGSS standards documents together. Please find the MS Waves and Electromagnetic Radiation handout. There is a separate module that reviews the details of reading the standards, but I'd like to take a few moments just to look at the general structure. So we're not going to read all the details on this page, we're just going to look at the architecture. Grab a partner and examine the document together. What do you notice? What do you wonder? Press pause as you complete this activity. One thing you may have noticed is the three colored areas in the center of the document. These represent the three dimensions of the framework: the science and engineering practices, or the things students do in the classroom as they learn science, like planning and conducting an investigation, asking questions, etc. The disciplinary core ideas, or the science content, and the cross-cutting concepts, themes that cross every field of science, like patterns or structure and function, and so on. The NGSS presents these three dimensions together, side by side. This is different from our Michigan content expectations, where our inquiry process expectations were listed at the beginning of the document. This side-by-side presentation conveys the idea that these three dimensions are inextricably woven together during the learning process, like the strands of a rope, and that deeper understanding is possible when all three are taught together. This diagram represents a new model for the practice of science. The practice of science, the way scientists do it, requires the ability to work in three spaces: investigating, evaluating, and developing explanations and solutions. The problem with conventional inquiry methods of teaching science is that too much time is spent on the left-hand side of this diagram and not enough on the right. We need to ensure that we focus on the minds-on practices of science, like reasoning and planning, and not solely on the hands-on practices, like observing and measuring. They're all important. So this brings us to the first conceptual shift of the new standards. K-12 science education should reflect the interconnected nature of science as it's practiced and experienced in the real world. In other words, we want our students to have the chance to be scientists. Let's consider some of the challenges and opportunities that might arise from this shift. Of course, your challenges and opportunities are unique to your environment, so please make sure you jot down some notes on your handout specific to your experiences. Please press pause while you consider these challenges and opportunities. One possible challenge might be that intro units on the scientific method or the nature of science aren't really needed anymore. Most textbooks and curricula start out this way, but it's not necessary when the practice of doing science is embedded in everything that's done in the classroom. Students will learn what science is along the way by doing it. Another possible challenge might be that new lab equipment or other resources will have to be purchased. The possible opportunities with respect to student learning are numerous. This shift will provide a more authentic experience for students so that they can begin to consider themselves as scientists. Also, the focus on minds-on science and the context and connections provided with the 3 dimensions result in a deep understanding of science. Let's take another look at that MS Waves and Electromagnetic Radiation handout. This time, let's focus up here at the top. The NGSS are written as performance expectations. These describe what a student should be able to do at the end of a unit. They're not meant to be lesson sequences or required activities. Teachers, schools, and districts will have to determine what student experiences will lead to these performance expectations. One really interesting thing is available when looking at the performance expectations in an online environment. At the top of the web page for each topic, you can choose which view you prefer. If you click on Practices and Core Ideas, the performance expectations become color-coded, showing how the 3 dimensions are woven together with each statement. Here you can see that for this performance expectation, develop and use a model to describe that waves are reflected, absorbed, or transmitted through various materials. The blue part refers to one of the science and engineering practices, and the orange part refers to one of the disciplinary core ideas. And if you click on the practices and cross-cutting concepts, the corresponding colors show up. Basically, each performance expectation is like the rope we looked at earlier. The 3 dimensions are woven together to illustrate how they fit together. So this brings us to the second conceptual shift. The NGSS are student performance expectations, not curriculum. It's not about lists of facts to memorize. Instead, the focus is on what students need to be able to do at the end of a unit. Again, as you consider this shift, think of challenges and opportunities that might arise in your situation. Press pause as you complete this activity. Some possible challenges might include, we still need to write the curriculum. We will have to consider what will work best for the students in our classrooms. As we set aside resources for determining lesson sequences, we will want to make sure we attend to the differing needs of our students, especially those Title I students who have historically struggled in our classrooms. Possible opportunities that extend from this conceptual shift might be that we have clarity about what our students need to be able to do at the end of a unit, and we get to decide how to get them there. Now we're going to consider the big picture. What happens with the NGSS as students move from kindergarten to 12th grade? Grab a copy of each of these handouts. Disciplinary Core Ideas, PS4 Waves and Their Applications in Technology for Information Transfer, an orange one. Science and Engineering Practices, Practice 2, Developing and Using Models, that should be blue, and Cross-Cutting Concepts, 1, Patterns, that should be green. Scan through these handouts with a partner. What challenges and opportunities are present in this structure? Press pause as you complete this activity. You may have noticed that the orange handout takes one of the disciplinary core ideas and shows the learning progression over time. This information is available for all of the disciplinary core ideas in Appendix E on the on the NGSS website. The blue handout takes one of the science and engineering practices and articulates the learning progression from K to 12. You can find these in Appendix F. And the green handout does the same for the cross-cutting concepts. Those can be found in Appendix G. And that leads us to conceptual shift number 3. The science concepts in the NGSS build coherently from K to 12. Press pause while you and a partner consider the challenges and opportunities that are unique to your classroom, school, or district that might arise from this conceptual shift. As we consider possible challenges for this shift in thinking, we will need to be mindful of gaps in student understanding. When concepts build from one year to the next, it's essential that all students are prepared for the next level. One important opportunity is that with this clear articulation of all 3 dimensions across the grade levels, it will be so much easier for teachers to build on prior understandings. Middle school teachers will know that they need to teach their students how to evaluate the limits of a model, knowing that in elementary school they learned how to identify the limits of the model. Okay, moving on, let's take another look at those Michigan content expectations next to the NGSS. Here's an example from high school physics. Here we have a list of the high school content expectations that have to do with force and motion. And over here is a list of the disciplinary core ideas that have to do with force and motion. I realize you can't read them, but it's important to just see what the list looks like. The Michigan content expectations ask us to teach a curriculum that is a mile wide and an inch deep. Students have to know so many different details and facts. The next generation science standards have narrowed the content to core ideas, but with the idea that these core ideas are taught along with the other 2 dimensions, the science and engineering practices and the cross-cutting concepts. The content may have gotten smaller, but that just made room for a deeper learning experience that does a better job of reflecting what scientists do. When you look at the entire NGSS document on force and motion, it's not shorter than the Michigan High School content expectations, but the smaller list of concepts is woven together with the science and engineering practices and the cross-cutting concepts. At first glance, it might seem as though this change might be easy to implement. Just stop teaching so much content. The problem is that teachers have done such a good job of doing exactly what they were asked to do, teach a mile wide and an inch deep. In order to make that experience as meaningful as possible for their students, teachers made connections for students all across that mile, to the point where it's almost impossible for them to consider teaching one thing without teaching everything. As we make the shift toward teaching less content in a deeper way, we'll need to rewire those connections. And that brings us to conceptual shift number 4. The NGSS focus on deeper understanding of content as well as application of content. With a partner, take a few minutes to consider the challenges and opportunities unique to your classroom, school, or district that might arise from this conceptual shift. Press pause while you complete this activity. While this is an exciting and welcome aspect of the NGSS, one challenge might be that teachers will need time to reflect and reorganize lessons and units. An opportunity will be that students will have more time to delve deeply into content. STEM is a buzzword everywhere in education these days. Let's take a closer look at the engineering part of STEM. The framework for K-12 science education breaks down each of the science and engineering practices into what they look like for science and engineering. Here is one example for the developing and using models practice. As you can see, scientists use models to develop explanations about natural phenomena, while engineers use them to analyze existing systems or test possible solutions to new problems. Students are expected to learn how to develop and use models from both perspectives. The intention here is that the engineering practices have equal standing with science practices. As we provide opportunities for our students to be scientists in our classrooms, we also must provide them with opportunities to be engineers. Here's another place where engineering shows up in the NGSS. The disciplinary core ideas include engineering design at every grade level. This is an example from K2. Also, there are engineering-focused performance expectations throughout the NGSS. Here's one for first grade. Use tools and materials to design and build a device that uses light or sound to solve the problem of communicating over a distance. And so that brings us to conceptual shift number 5. Science and engineering are integrated in the NGSS from K to 12. Again, take some time to consider the challenges and opportunities that are unique to your situation, and press pause while you complete this activity. This shift will be brand new for many science teachers. They will need to learn about the engineering design cycle and find ways to challenge students to use it within the context of their content. By integrating engineering with science, students will be able to deepen their understanding of science by applying it through engineering. The authentic nature of engineering tasks might also serve to inspire students to pursue careers in science or engineering. Turn to your partner and discuss, what's the purpose of K-12 science education in today's world? Press pause while you complete this activity. The framework for K-12 science education provides this purpose for K-12 science education. The overarching goal of our framework for K-12 science education is to ensure that by the end of 12th grade, all students have some appreciation of the beauty and wonder of science, possess sufficient knowledge of science and engineering to engage in public discussions on related issues, are careful consumers of scientific and technological information related to their everyday lives, are able to continue to learn about science outside of school, and have the skills to enter careers of their choice, including, but not limited to, careers in science, engineering, and technology. With your partner, take a moment to discuss, in what ways might this purpose pose a conceptual shift for K-12 science education? How is it similar and different to the purpose you and your partner discussed? Press pause while you consider these questions. This brings us to conceptual shift number 6. The NGSS are designed to prepare students for college, career, and citizenship. This emphasizes that science is not just for gifted and talented students. Science learning is essential for all students. Take a moment to consider the challenges and opportunities that are unique to your situation. Press pause as you complete this activity. This will be challenging as we shift our instruction to meet the needs of all learners, but many of the practices prescribed by the new standards will make that easier. For example, social interactions, such as engaging in argument from evidence, will make science more accessible as all students in a class work together to construct meaning. With the Common Core state standards so new, many teachers, especially at the elementary level, wonder about having to add a whole new set of standards right now. But one of the most powerful things about the NGSS is that they were written with the Common Core state standards in mind. At the bottom of every page of standards, connections to Common Core, ELA, and math are outlined, so that as teachers ask students to read, write, speak, model with mathematics, apply a mathematical concept, etc., they know exactly where students are with those skills and concepts. Also, if you take a look at the NGSS, the Math Common Core State Standards, and the ELA Common Core State Standards, all three require that our instruction focus on practices that are specific to each discipline. So the NGSS has science and engineering practices. The Math Common Core have the standards for mathematical practice. And the ELA Common Core have the capacities of a literate individual. If you look at all of these side by side, they look like this, but an even more compelling way to look at them is with a Venn diagram. Here are the disciplinary practices depicted in a Venn diagram. As you can see, the overlap area in the middle shows that at the center of everything is the engaging in argument from evidence practice. For conceptual shift number 7, the NGSS and Common Core state standards in English Language Arts and Mathematics are aligned. Please take a few moments to consider the challenges and opportunities that might arise from this conceptual shift. Press pause as you complete this activity. For this conceptual shift, the challenges and opportunities are really the same. It makes sense to integrate science with ELA and math, but we have to figure out how to do it. The NGSS document helps tremendously with this task by delineating the connections, but putting them in practice will be difficult. In summary, the NGSS are based on 7 conceptual shifts that change the way we look at K-12 science education. Of course, the real question is, how do these shifts play out in the classroom? If you think back to our card sorting activity at the beginning of this module, the things scientists do and the things students typically do in K-12 classrooms are different. Moving forward, we need to consider thinking about a Venn diagram instead of a T-chart. And as we implement these new standards, we'll need to find ways to move the things scientists do to the center of the diagram, while moving those things that have historically only been done by students off the diagram. In closing, take a moment to reflect on your first steps. As you consider your classroom or school or district, what are some new ways you might support your students in being scientists?